I want to just introduce the roof concept on this one here. So again, I have my studs, I have my rafters, everything is grand there. I want you to particularly to look at the detailing that I have in here. Just to make a point, he has this service bay. That's what them horizontal battens are for, that there. He has this service bay. This is where he'll run all his services, his electrical and piping services. And he has taken the extra decision, well, I'm going to insulate it as well. I'm going to put insulation, and that's perfectly okay. Just remember, you cannot put insulation directly against electrical cables that are live. You can't, because you have to have an airflow from them. So maybe it's better to put a conduit in, let the air flow. So just to make that point. But again, if I want to be critical of it, we have this warm board on the inside. So the services have to come through the warm board, which is the thermal bridge issue. And it's always better if I can have my lovely comfortable sandwich, the airtight, the insulation, the wind tight outside and keep everything inside. So if I was changing this, I'd be putting that there, bringing the batten out and then plastering over. But again, the argument is an extra layer of work to be done. A lot of extra details in here. He has a window ceiling detail. He has his little grommet on his electrical cable coming in. But it's the roof I want to just focus on. So I've showed you a couple of details of walls. And we'll have a look at, there's a couple of really big ones there we'll look at. But just to focus on a couple of little details, I'm going to switch myself over to this side and I'm going to look at this roof detail. So what we would have traditionally done in the past, we would have insulated into the rafters. We would have stuck insulation in there. We're sort of moving away from that now on its own. We are still doing it, but we're moving away from it. So there's insulation in the rafters. That's grand. And in this example here, there's an extra layer of insulation outside. So the thermal bridge is dealt with on the outside of the entire construction. So I'm not worried about how it's going to be in terms of thermal bridging. And in this model here again, and the requirement here is for 0.16 in terms of U values, 0.16, which is quite a tough value to achieve. So I need a bit of thickness. So what he has is he has 80 millimeters of an external insulation here, Gutex in this case. He has insulation, it's hemp in the actual construction, and then he has this extra warm board on the inside. So if I check the U value on it all, just about making what I'm required to in terms of the building regulations. The problem is it's adding thickness to the roof. It's making the roof section much bigger. And if I increase the thickness on the inside, which is traditionally, well, I'll just stick a warm board on the inside there, the headroom has been reduced. And now we're thinking, let's put it on the outside. The downside is that my roof is risen by that extra bit, and the fascia and soffit detail might just be a bigger, chunkier section. But there's a couple of points I want to just draw your attention to here. First of all, I'm just going to turn it just slightly around to us here. You may notice on top that it's double battened. So we don't do that in Ireland, but we may have to start to think about that. So traditionally the ventilation was on the inside for bituminous layers. They would gather moisture and the moisture would re-liquefy and it would start to drip. Your insulation would get ruined and your timbers would start to rot. So in modern construction, we're talking about using breathable layers. So the actual moisture will come through the layer, but then we need to get it away. And the way we're getting it away is we have this ventilation space. This issue came up this morning and we'll come back to it now. So I want to let air flow through the construction to take away any moisture that will gather there. Remember, it's freezing cold here on top of the slates or tiles. It's lovely and warm in there. The moisture comes out. It'll re-solidify here at this level. And then we just need to blow it away with a bit of airflow. So this double battening effect. So what we're doing is we're battening down on top of the rafters in the same direction and then we're cross battening in the other direction. So that's an unusual detail in terms of Irish construction, just to say. So we probably will be doing that much more extensively in the future. Now, another point that I want to make here. So I need to let air get in to there. And I can do that in a number of ways. You were talking about ventilated eaves and so on, so we'll come back to that. But there's two things I want to do. The water that may flow off this, so remember, this is the secondary protective layer for the roof. If the tiles get broken, then the water gets through and I want to get it away. So I want that water to get into the gutter or to get off the roof. And that has a sort of a contradiction for what I really want to achieve, because I also want to achieve wind tightness. So if I cut that like that there, it'll do the first bit, which is the water bit, but then the wind gets in there. So what's really ideal is that if I'm looking for a perfect detail here, is that when I come to do this work, that I'll use a narrow strip of my membrane at the end here. Are you okay with that? I'll bring a membrane around and under there, and I'll seal off. So now that's the wind tightness taken care of. And then before I introduce the second layer to tape off, I'll bring in a second piece just to run into the gutter. So now that takes care of the dripping. That one takes care of the wind, and then I just carry on with a single layer. Is that making sense to you? Do you see the detail that I'm going to? It's just to make sure that everything is covered off. So there's no bother to achieve what we're trying to achieve in terms of the overall. So the argument there this morning was around this ventilator. There's a little device I can fit now on top of the fascia to let that air in. Traditionally what we do is we provide a tray there to stop that ponding effect. And this fella here, he's ventilated, so he'll go underneath there. So my fascia will come up to there and the air will get in. So you can see when he's sitting in place, the air is actually flowing in there to give that space. So that's, I think, what you were talking about. I can't remember who it was. I think that's what you were talking about this morning.
You have to tape the felt.
Yeah. So what happens is that instead of bringing the layer down, what I'll do is I'll put that in instead and tape that to that so the water will naturally flow and the ventilation is getting in. Okay, so there's a series of different products I can use. So that's a nice construction. You can see that he has, you know, he has an outside cladding of some sort. He has a ventilation space. He has his layer of insulation to eliminate the thermal bridge. His wind-tight layer. His structural strength. His insulation in the timbers, and on we go through. So we're getting thicker and thicker and thicker in terms of what we're trying to do. So that's a nice little construction there. A couple of little faults in it, but we won't point them out.